Hello everyone and welcome back to the course. Today we're calculating our way into propositional calculus and making some serious logical moves with inference. Just as there is a theory for performing calculations with numbers, meaning arithmetic, and even with more complex ideas such as differential and integral calculus, there are also precise rules for handling propositional formulas. And this is what we call propositional calculus or rules of inference. In this section, we will explore key logical inference rules that will allow us to determine the truth of a thesis based on some other premises. More precisely, we will explore the following inference rules: logical simplification, logical addition, logical transitivity, modus ponens, modus tollens, and some other ideas. Let us analyze the inference rule called logical simplification, meaning P and Q implies P. Consider the proposition dogs bark and bite. This proposition logically implies each of the following: dogs bark and dogs bite. We are using the fact that P and Q logically implies P. This can easily be verified using truth tables. If we check the truth table of this propositional formula, we notice that this represents a tautology. An important observation is that P does not imply P and Q. Let us consider now logical addition, meaning P implies P or Q. Consider the proposition, students are competent. This proposition logically implies that the students are competent or teachers are unfair. We are using the following fact: P implies P or Q. The truth table confirms that this propositional formula represents a tautology. Notice that P or Q does not imply P. Let us consider the next inference rule, modus ponens. P and P then Q implies Q. Consider the propositions John bought a movie ticket, denoted by P, and John has the right to enter the cinema, denoted by Q. The proposition P implies Q states if John bought a ticket, then he has the right to enter the cinema. If we accept both P and P implies Q, we can logically conclude Q. If we check the truth table for this, we notice that this represents a tautology. Let us consider the inference rule modus tollens. If P, then Q, and not Q implies not P. Consider the propositions. If it rains, then I will go to the cinema, which will be represented by if P, then Q. And I did not go to the cinema, not Q. If we accept both propositions, we can logically conclude that it did not rain, not P. This is an example of the rule modus tollens. If we check at the truth table, we notice that this represents a tautology. We have checked some of the most important inference rules used in propositional calculus, but those are not all of them. Here you have a list of some of the inference rules that are mostly used in propositional calculus. Well, this is all for today. Thank you very much for following this video until its very end. In the next lesson, we will put into practice all of these rules of inference in order to determine valid reasoning. See you in the next lesson.